Hello everyone. In this video I'm going to be showing you how valuable it is to put something like an API gateway in front of your backend microservices and the value in terms of how the gateway can send analytics over to something like Elasticsearch, which is a database or a database or kind of search engine, and viewing that within Kibana. So we're going to be trying to show how you can solve various problems using this. And what I've done is created a Docker Compose, which is which you can follow along if you want to. Docker Compose.yaml. I'll be going through what each of the bits do, and there's some examples in the README there as well for you. So if we head over to the Docker Compose and have a look, we can see we've got our Elasticsearch server. We have our Kibana, which is like our UI, which we're going to be browsing, exposed on port 5601. We're starting up a Redis server. This is what our API Gateway Tyk uses for temporary analytic storage and storing of session tokens, rate limits, quotas, etc. And we have a pump component, which is a open source component, which can send your analytics over to data sinks such as Elasticsearch or say MongoDB, various other data sinks, whether that be Prometheus, StatsD, wherever you want it to go. And we also have Tyk, which is the API gateway I'm using for this example. And what we're doing is we're mounting the configuration, which is the apps, into the container. So it's completely declarative syntax. No, you can use the APIs if you want to, depending on what your specific configuration is. But I'm just going straight with deploying the API definition configurations into the Tyk gateway, and also policies, which is like the security policies, what we're allowed to gain access to, what we're granting access to, etc. So for simplicity, within Docker, and so that I don't spam the excellent HTTP bin service, this is a request response service which allows me to send API calls. This is going to be my backend service. So, without further ado, let's get started. Copy the URL and then clone that. CD into there, and then Docker Compose up -D for detach mode, and we'll wait for those services to start up. All up and running. Okay, and we can see that we have our Elasticsearch, our HTTP bin service, Kibana, Pump, Redis, and our Tyk gateway. Now the only one where we've exposed the ports is on 5601 for Kibana and 8080 for the Tyk gateway. So let's have a quick look to see localhost :5601. Server's not ready yet, so maybe it's taking a few seconds to come up and running. And we're in. But at the moment we don't actually have any data in our Elasticsearch cluster. So first of all, I'm going to be curling the HTTP bin service directly. And if I send a GET request, and I can get a response coming back, you can see these are the standard curl headers that get sent. If I add a query string, got to escape that, and then you can see that we found these arguments. So and if I add a header, and we can see it picks up these headers. So it's a nice way of testing my request response service. Okay, but the problem is I don't know how my microservices or my services are being consumed. I have no visibility of this. If there's an error for any reason, and it throws a 500 error, yes, I'm going to get my 500 internal server error coming back. But I don't have any analytics. I've got no way of observing that, querying that, or finding out any information. So what we've done now, using the gateway configurations, which is, I'll have a look at the data quickly so you can see that nice and clearly. We can open up Tyk and go into apps, and we've configured the gateway to reverse proxy to the HTTP bin service. I'm just going to go through really briefly what each of these configurations options do. So we've got an API name, HTTP bin, an API ID, which is HTTP bin also. Use keyless true, which means that this API is not authenticated, it's just a transparent reverse proxy. We've got a bit of version data, proxy listen path, so we're listening on the HTTP bin path. We can do host-based routing, but for simplicity, I've just set it up as path-based routing, so when the gateway receives the request on the HTTP bin path, what it will do is identify that this belongs to this particular API, and it will strip that listen path before reverse proxying to the HTTP bin service. The API is active, and there's not much else that's interesting there. So what I should be able to do is curl the gateway. I'll do that in this window here. So it's the HTTP bin service / maybe hit the get endpoint, and you can see that the gateway has received the request and then reverse proxied to that HTTP bin service. And I can do the same thing here. Okay, it didn't reply. I need to just do -I, and then we can see the headers that came back. It's an internal server error. Let's try /XML, and then we get an XML response coming back. So now that we've got that, let's head over back to our Kibana dashboard and refresh that page. We should have hopefully explore my own, or maybe that's why, discover. So what I need to do now is create an index pattern. You can see that we've got this Tyk analytics that's been started showing up. It's detected that there is some data in that Elasticsearch cluster. And just to show you quickly, Docker compose PS, we have our pump service, which is here. So Docker compose logs follow pump. And then we can see that we've been writing analytics to Elasticsearch. Now I've got it to send every 5 seconds. You can increase that or decrease that. It's completely up to you. But if I send that request to there again, and then you'll see we're writing a record. If I change that to use Docker Hey and send 100 requests to that XML endpoint, I think, what did I do wrong? Let's try Apache Bench. And then we send some requests, and then hopefully it should have writing a record. I only just sent one for some reason. Try 100. Okay, and then it started chunking those requests. So it wrote 20, wrote 80. So now it chunks those requests and then sends them as it gets there every, say, 5 seconds. And we can head back over to our dashboard and then define our index pattern. And then next step, and then we can find our timestamp and then create that index pattern. Okay, and you can see it's picked up all of these fields that for all the analytics that we're sending over to, if I hit the Discover button, sending the analytics over to the Elasticsearch database. So what you can do, I mean, we've got all this analytics for all of the traffic that's coming in auto refresh. So you know, as the time goes by, we can send more requests through, and as time goes by, we're going to get more and more requests coming through. That's all great, and what we can then do is query based on you know, if there's a problem or anything like that, you notice there's some problems, then you can maybe query based on the response code. So we can now say response code :500, because we did get some 500 errors, and then we can see those with those two 500 errors. You see how nice and quick that is. Obviously, Elasticsearch is a big database. You might have to set up clusters and things like that, and I don't know how, you know, you have to look a lot deeper into how to configure Elasticsearch properly, but you know, it's great. So if I update that, I've got all of my requests now. Let's find a more interesting API which was configured, and this would be the same HTTP bin service, but I've protected it using a JSON Web Token. So I've changed a couple of things here. For simplicity, I chose HMAC, but you can also do RSA, public-private keys as well. JWT source, so this is the shared secret. It would normally be the public key if it's the RSA public key, but as a shared secret, this particular shared secret is base 64 encoded shared secret. So ZM9V, and I can prove that to you quickly. I can echo -n, and my shared secret is foo, and then I can pipe that to base 64, and then you can see that's the base 64 encoded shared secret. So the JSON Web Token that we create, what we're saying is that the identity, who this user is, that's in the subclaim, and we're applying a default policy, which is a security policy, to this particular API. So the access rules are defined by this particular policy ID. I'll go back, I'll show you the policy later. We've set a few other configuration options here. What we're doing is stripping the auth data. It's obviously, if I decide to send a curl request to this particular API, and maybe I won't hit the, so now I've got my my credentials. That might be a JWT, it might be a bearer token, it might be anything. It could be, you know, basic core credentials, etc. And obviously the backend service is getting this, and obviously this could be a security risk. So what this option does is strips that authentication data out of the request before it goes on to the upstream. That's another benefit of having something like an API gateway rather than a simple load balancer like, say, Nginx or HAProxy, etc. You've got all of this kind of API context related stuff directly baked in. We've got enable context variables. So what this allows us to do is take information about the request context and inject that into body transforms, header injections, etc. So I've turned this capability on, and in here what I'm doing is saying for every single request, get information from the request context, the Tyk context, and extract from the JWT claims the subclaim. So what I'm doing is I am injecting the user, creating a user header and injecting the subject from the JSON Web Token into the request. And then what I'm also doing is tagging the header's user. So this will then extract from the header the user header, and then inject that into my analytics. So I can see user user information in my analytics without actually having to record the entire request and response or all that kind of stuff. So this is all obviously baked in. So let's go about creating, or let's send a request to the API first. So same kind of thing, using the wrong API key, and this particular API is HTTP bin-JWT. I've just this is my listen path, and I send the request, and I can say, oh, it contains an invalid number of segments. So this particular JSON Web Token doesn't have the required number of segments, which is the header dot body dot signature. So let's create a JSON Web Token. And in here we have a subject, and I'm going to call this, let's say, foo@bar.com. Name, so I can put my name in there. I'll keep it really simple. I'm not going to go into the full capabilities, and I'm going to create the wrong secret now. So I'll call this, wrong secret, and then I'm going to copy that JSON Web Token and then head back over here, and I'm going to replace that bearer token with the wrong JSON Web Token, and then we can see keys not authorized, signature is invalid, and what I can do is I can do that again and use the I, and we can see 403 forbidden, so the key's not valid. What we should be able to see if we head back over to Kibana is that a couple of requests have also come through here, so we can check some of the issues with what's going wrong. Our users are trying to log in, but obviously they're not able to. You can see the response code was a 403. Heading back here, or back to the JSON Web Token, we'll create the correct JSON Web Token now. So let's put the right secret. And now, if I copy that and paste that in there, I'll just do -I as well, and then we can see we're now allowed through. So the gateway has validated the signature of the JSON Web Token. The gateway removed the JWT, so it's removed the authorization header from the request to the HTTP bin service. It's also injected the username foo@bar.com from our JWT here into the header, and hopefully, if I send a couple of these requests where it lets me through, that's all very good. And what I'll also do is send a request to status /500, and then we're getting an error coming back. Maybe we'll send a status error to what's another one? Oh, 422 unprocessable entity, because I've sent a request which is invalid for whatever reason, so sent that as well. And so I've got a client error, a couple of client errors, a couple of internal server errors, and these records are just constantly writing, being shipped to Elasticsearch. Let's head back over to here, discover. Let's have a look, because the customers now complained that there are problems for whatever reason, and customers complain that there's problems for whatever reason. So what I can now do is write a query, and I can say, oh, hold on a minute, to the customer, what's your username? And they'll say, oh, my username's foo@bar.com. So I can just head over to my Kibana dashboard, and I can search for user foo@bar.com. And awesome, I can see all of the API calls that they've made, and maybe I can apply a filter, but I mean, I'm not going to go into the specific details of what you can do. But we can now see all of the API calls that particular user's made. So it's really, really valuable insights into what's going on to help me debug this particular problem. Obviously, you can create your own visualizations. You can create your own visualizations. You can build various gauges or line charts, if you wanted to go down the route of, I don't know, let's have a look at the kind of metrics. You've got, mean, mode, and percentile ranks. So if you wanted to have a look at the information about, say, the median request time, but you can go build your own visualizations, you can go build your own dashboards, and all kinds of other really, really cool stuff. So that's pretty much it. Feel free to bounce over to this repo. Oh, I forgot to show you the policies. So this is like I suppose a JSON map. So this was the policy ID. The ID here, we're specifying a rate limit, 100 requests per second. This is a global rate limit for the key, and then you can define the access rights for that key. So that JSON Web Token is able to access that HTTP bin service. If I want to grant access to multiple APIs, that's absolutely fine as well. The policy object can get more and more complex. So for each individual API that the key has access to, they can all have their own rate limits and quotas and etc.